Refractive index of glass by shift method, normal shift method. We use a traveling microscope for measuring that shift. Remember the main mistake that you commit here while drawing the ray diagram. So object is here. Whatever the markings that or the powder that we keep below the glass slab. This is the glass slab. A, B, C, D is the glass slab. And so one ray incident normally or coming normally from the object, it passes without any deviation straight into this. And another ray which is incident at an angle, it bends away from the normal because it is moving from denser to rarer medium. And that ray which is moving like this is produced backwards, that is dotted line. And there too, this direct ray which is incident normally and the ray which is bent like this, they appear to come from this point, that is the image. So that is the method of drawing the that ray diagram. Don't draw some rubbish ray diagrams, okay? So two rays you have to consider. One is coming from the object, incident at an angle, it bends away from the normal and it appears to come from this point. Another ray which is incident normally on the surface passes undeviated. They appear to come from here. This is the image. So this is normal shift and this is real depth, you know it. And this is apparent depth. The depth at which it is kept is apparent depth. So real depth is reading R3 minus R1. That is real depth. What is apparent depth? R3 minus R2. R3 minus R2 is apparent depth. And you know the formula, n equal to real depth by apparent depth. That is real depth is R3 minus R1 by R3 minus R2. So very easy experiment. Only the thing is taking the readings in the traveling microscope. So you have to take readings here. Okay. So when you keep the glass slab over any printed letters, they appear to be shifted upwards like this. Okay. So you can see it here. These letters appear in the same position, whereas these letters appear to be shifted closer to you. That is because of this glass slab. Okay. Now, while taking the readings in the that traveling microscope, this is the vernier scale. You know this. Okay, I'll change the color. Yellow, yes. Now, remember these readings, you have to take care that this is the vernier scale, and in the vernier scale, this is 0. This is 10. That's what you have to treat. This is 20, not 0.2. This is 30, 40. There are 50 lines. There are 50 lines in the traveling microscope vernier scale. This is 0. 1, 2, 3, 4, 5. This is 5. 6, 7, 8, 9, 10. Or if I can mark it here, this is 30th line. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So there are no decimal readings in the vernier scale. They are taken as full lines, integral lines. So 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. So 50 lines in the vernier scale. What about the main scale? In the main scale here, it is a little different from our ordinary scale. In an ordinary scale, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 1 centimeter. Between 0 to 1 centimeter, we have 10 lines. So 1 centimeter is divided into 10 lines. That becomes 0.1 centimeters. So if you have this one as 1, then the next line will be 1.1, 1.2, 1.3 like this. So this is 0.5. But if you divide it again into smaller parts like this, 0.1 centimeter is also divided into smaller parts like this. Then what happens is, between 0 and 1 centimeter, you will have 20 lines. So 1 centimeter will be divided into 20 parts. That comes to 0.05 centimeters because 0.1 centimeter earlier value is divided again into 2 parts. That comes to 0.05 centimeters. That is the least count of the traveling microscope. So if this is 5 in the traveling microscope, MS main scale. So in the vernier scale we have seen, in the main scale if this is 5, then the next line, this one is not 5.1, it is 5.05 because you have to add 0.05. Next one is 5.1. So next one is 5.1. Then after 5.1, it is 5.15. Then 5.2. So if you have the main scale like this, if this is 5, 5.05, then 5.1, 5.15, then 5.2, 5.25, 5.3. So this is a 5.05, this is 5.15, this is 5.25. So it keeps on with 0.05 for every division. That's why it is very accurate. Okay, so that you have to take care of. So while calculating the this least count, you see value of one main scale division. Value of one main scale division is 1 centimeter divided into 20 parts. So 1 centimeter divided into 20 parts, that is 0.05. The number of divisions in the galvanometer, vernier scale divisions is 50. 50 divided by 0.05 is 0.001 centimeters. So least count is value of one main scale division divided by total number of vernier scale divisions. You have to continue this. Value of one main scale division, change once, color, yeah. Value of one main scale division, that is 0.05 centimeters divided by number of divisions in the vernier, that is 50. That comes to 0.001. So don't neglect these two zeros. Some people take it very lightly and write as many zeros they wish. That will be giving wrong answer. So 0.001 centimeter. That is least count. Okay. Now how to take the reading? So how to take MSR and VSR? That is very important. Now if you look into some values here for example, now the vernier scale reading, you know that this is 0. Shall I change some colors? Whether this color is okay or blue color, is it ever? No, not seen. Red is okay, I think. Yeah, red is same. This is 0. This is 10. I have asked you to change this. 20, 30, 40, 50. Between you have 10 lines each. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like this. So this is 45, 46, this is 35, this is 36, this is 39, something like this. This is 49. Okay. Now what is the main scale reading? This is 10, 10.1, 10.2, 10.3, 10.4. If you see here, this is 10.5. 0 has little bit crossed 10.5. So MSR is 10.5. If it has crossed, you have to write the previous line. MSR is 10.5. You can see that. 0 has crossed 10.5. 0 has pushed away from 10.5. This 0 is little away from 10.5. You can't write 10.45, this line. This line you can't write it because it has already crossed it. 10.5. What is CVD? Now you can see here, this line which you have written 10.5 and the main scale, that's vernier scale reading, are very, very close. If they are very, very close, then the coinciding division will be very less. You see, these two are not in straight. These two are not in straight. These two are not in straight. Not in straight. This is almost in straight. This is okay, almost in straight. So you can write either these two, this one or this one. What is that line? 5 or 6. I'll write 5. But there is no reading for this. This is fifth division. This is 10.5 centimeter. MSR has centimeter scale, whereas CVD has no reading. It is simply a number of divisions. Okay, that's one reading. What about reading here? Let us see what is the reading here. Reading here is, you see, this is 10.5 itself, but 0 has crossed much. It has crossed away from 10.5. You can see that. You can rub this and you can see that. I will put it in dots only. 10.5 is here. This is little bit away. So here, this reading is very close to 10.5. 0 is very close to 10.5. So main scale reading is 10.5 and coinciding was only 5 or 6. That's what we have got. But now here you will find that the coinciding is little bit more because this reading MSR is 10.5 itself. MSR 10.5 centimeter. What about CVD? See, this is little bit away, right? So coinciding division will be more. So you totally have 20, 30, 40, 50 lines. So the middle will be 25. Less means bit less than 10. More means more than 40. Divide it like that. Since this has just crossed 10.5 and this is not very close to it, coinciding will be around more than 10. So this is not coinciding, not coinciding, not coinciding. But it is coming closer, closer. Somewhere here it is coinciding. I think you can see that in either these four lines, any one is coinciding. If one or two lines change, no problem. You can write any coinciding. 25, 26, 27. I'll write 26. Either 26 or 27 or something is coinciding. You can see that. Or this 28 also. That's also okay. This one, 28. It is coinciding. 2800. Okay. Then this is another reading. See here. Now, here, this is almost, okay. Yeah. This is almost here. It is 10.55. It is not 10.5. This is 10.5. It has crossed the next line also. So MSR is 10.55. What is CVD? CVD is somewhere here, right? This one or this one. You can write it as 9, say 9. Ninth division. No unit for this. Okay. Here. Actually, it appears vertically. So now you can take a reading here. So if you want me to zoom it, yes, you can zoom it and you can see that. Now, what is the reading? So 0 is here. This is 0th line. Okay. Yeah, 0th line. This is 10. This is 20. This is 30. You have anything? Yes, 40. Rest of the things you can't see them. But no problem. You need not have to do that. See here, this is the point where the 0th line occurs. But this line is here and this line is here. What are those lines? Now, this line, 0th of the vernier scale has crossed this line. It has crossed this line, but has not met this line. It has not met this line. It has crossed this line. So you have to write the previous reading. What do you mean by previous reading? So you are not supposed to take this reading because it has not reached, this line has not reached this line. So you have to take this reading. What is this reading? If this is 6, then this is 5.9, 5.8, 5.7, 5.6, 5.5. This is 5.4. That means, what is this main scale reading? Main scale reading is this one. 5 point, this reading you have to take because this line has crossed that reading. So it is 5.45. So MSR is 5.45 centimeters because it has crossed 5.45 and it is moving towards 5.5 but has not reached 5.5. So 5.45. And what about coinciding? See, these two lines are not coinciding. This is not coinciding. Not. Which is coinciding? Not coinciding. It is very far away. So where you can find the coinciding line then? Maybe somewhere above. Yeah. Somewhere. We don't get it anywhere here. Maybe in 1 minute. Yeah, it has crossed 5.45 and it is very close to 5.5 means it's somewhere above. We can't see that yet clearly here. It may be somewhere here, or it has crossed that. Somewhere here you may get it. I can't see that since the photography is not very clear. It may be some 40, more than 40 also, not possible. So it cannot be seen here. Say 45, 46, something like that. Okay. Then, yeah, that's how you take the reading. Can I see if I make it smaller? Coinciding one, we should have taken above, still above. Yes. Okay, let it be. So once you take the reading, see, remember in all of the readings here, MSR has the fraction 5.9, 5.4, 7.8. You can have even 7.85 also. That is also possible. But CVD is simply a number 5, 18, 41. This cannot be. This cannot be the CVD. CVD should be 33 and things like that. Okay. So when you go for calculations, say I have a calculation for this one now. That is better you see one calculation here. This one. How did I get 5.905? MSR plus CVD into least count. You have to do this first. That is the total reading. That implies total reading is equal to MSR 5.9 plus CVD, coinciding vernier division is 5, into least count 0.001. Usually you forget 1 0 here. It is 0.001. Yes. So what is the total reading? That implies total reading is equal to 5.9 plus 0.005, because if you multiply this to 0.001, 0.005. So 0.005 has to be added here, 5.9. It will be 5.905. That is the answer. So in this way, you find out all the readings. So you know the practical part, that you have to focus it to a powder or any mark on the base, get the reading, lift it, keep the glass slab, lift it till you see the image. Again, you place the mark on the surface of the glass slab. All that part I don't want to explain, that you can do. So taking readings is very important. Thank you.